So an arithmetic sequence is where each term keeps going up or down by the same amount. Okay, so for example, this here is an arithmetic sequence because each term in the sequence keeps going up by 2, like this here. This is an arithmetic sequence because each term keeps going up by half. And this here is an arithmetic sequence because each term keeps going down by 3, like this here. Now, at A level, you need to be aware of the notation UN. Now, this is essentially, if you think about it like GCSE, this is the nth term, where the n describes what term we're talking about. So for example, if we're talking about u1, this is the first term. If we're doing u2, this is the second term. If we do u3, this is the third term. So for example, if we're talking about this sequence here, u3 is going to be the third term, which we can see is 6. If we look at this sequence here, if we're talking about u4, this is the fourth term, which we can see is -7. So for an arithmetic sequence, we have a formula that can figure out any term in the sequence. It's this up here, where un is equal to a plus n minus 1d, where a is the first term in the sequence, d is the common difference, this is how much each term keeps going up or down by, and n, as we've already talked about, is the nth term. This is not given to you in the formula booklet, so you'll have to remember it. Okay, so let's use the example we talked about at the start, where we have the sequence 2, 4, 6, 8, and we need to find the fifth term, or in our notation, this is u5. So we're going to use this formula here. So a is the first term, and we can see that the first term is 2. So a is equal to 2. So the common difference, as we talked about, each term keeps going up by 2. So therefore d, the common difference, is 2. And we're trying to find the fifth term, so it's u5, so therefore n is equal to 5. So therefore what we're going to say is that u5 is equal to a, which is 2, plus n minus 1, so it's going to be 5 minus 1, and then this is multiplied by d, which is 2. And if you figure this out, this is equal to 10. So u5 is equal to 10. This is one of the other examples we talked about in the intro, where it's 5 over 2, then 3, then 7 over 2, and then 4, and we need to find the 50th term, so this is u50. So we're going to use this formula here. So a is the first term, so here a is equal to 5 over 2, and then the common difference, it keeps going up by a half, so therefore d is equal to half, and then n, so we're talking about u50 here, so n is equal to 50. So therefore u50 is equal to a, which is 5 over 2, plus n minus 1, so it's going to be 50 minus 1, multiplied by d, which is a half. And if you put this into your calculator, you'll get that u50 is equal to 27. Okay, so here's an example question where we're told the first 4 terms of an arithmetic sequence are 11, 20, 29, and 38. And for part A, we need to find an expression for un in terms of n. Okay, so I've given you the formula here for un. Remember, again, this is not in the formula booklet, so you will have to remember this. So if we look at this sequence, we can see that the difference between each term is +9, like this here. So if we use the formula for un, so a, which is the first term, we can see that this is 11, so a is equal to 11, and then d is the common difference, and we can see that this is equal to 9, and then n is the nth term, and we're trying to find an expression for un in terms of n. So we're just going to say that n is equal to n, like this here, okay, and then figure this out, okay? So we're going to say that un is equal to a, which is 11, plus, and then n minus 1, so we've still got this n here, so it's going to be n minus 1 multiplied by d, which is 9. I'm going to rewrite this slightly as 11, and then I'm going to move this 9 to the front of the bracket, so it's 9, and then n minus 1, like this here, so it's in a bit more of a familiar format. And then if we expand this bracket, it's going to be 11, and then 9 times n is 9n, and then 9 times minus 1 is minus 9, like this here, and this is going to be 9n, and then 11 minus 9 is 2. So therefore un in terms of n is 9n plus 2. Okay, and then for part B, we need to find the 22nd term in the sequence. Okay, so this is going to be where n is equal to 22. So this is going to be u22 like this here. So if we sub in n as 22 here, it's going to be 9 times 22 plus 2, which if you put this into your calculator is equal to 200. So the 22nd term is 200. Okay, and then for part C, we need to find the value of n for which un is equal to 677. Okay, so the question is essentially asking what term is equal to 677. The way that we're going to do this, as un is equal to this here, we're just going to say that 677 is equal to 9n plus 2 and rearrange to find n. So if we bring this 2 to the other side, so we get 675 is equal to 9n. So therefore n is equal to 675 divided by 9, which if you put into your calculator is equal to 75. So that means that u75 is equal to 677. The 75th term in the sequence is 677. Okay, so now we're going to start talking about series, okay? So hopefully it's pretty simple what a sequence is. It's like this here, where it's a sequence of numbers. A series is where the numbers instead are added together. So these two here are the exact same set of numbers, but this one here is a sequence and this one here is a series. Okay, so for a series, you need to be aware of a similar type of notation, which is Sn. This is essentially the un for a series. So this is the first n terms added together. Okay, so for example, let's look at this series here. If we're talking about S3, this is going to be the first 3 terms added together. So we can see that for this series here, it's going to be 2 plus 4 plus 6. So therefore S3 is going to be equal to 12. If we're looking at this series here, let's say that we're talking about S4, this is going to be the first 4 terms added together. So in this case here, it's going to be 5 over 2 plus 3 plus 7 over 2 plus 4. And if you put this into your calculator, this is equal to 13. So like un, for an arithmetic series, there is a formula for Sn. So Sn is equal to n over 2, 2a plus n minus 1d, where a is the first term in the arithmetic series, d is the common difference, and n is the nth term, which is the term that you're adding up to, okay? This formula is given to you in the formula booklet, okay? Now, they also give you another formula in the formula booklet, which is this here, where Sn is equal to n over 2 a plus l, where l is the last term in the series. 90% of the time you're going to be using this formula here. This formula doesn't come up that much. The reason it doesn't come up is in order to use it, you need to know the last term that you're adding up to, which a lot of the time you won't. Like, especially if you're going up to a higher value of n, like S50 for example, it's unlikely that you're going to know what the 50th term is, okay? So a lot of the time you're going to be using this formula up here. Okay, so for example, let's say that we want to find S9 for this arithmetic series up here, okay? So we're going to use this formula down here. So A is the first term, which we can see is 2, and then D is the common difference, and as we talked about before, this series keeps going up by 2, and n is the nth term that we're going up to, as it's S9. This is going to be equal to 9. So therefore S9 is going to be equal to, if we use this formula here, it's going to be equal to n over 2, so 9 over 2, and then 2a, so 2 times 2, plus n minus 1, so 9 minus 1, multiplied by d, which is 2. And if you put this into your calculator here, this is equal to 90. So this is the sum of the first 9 terms. Let's say for this arithmetic series here, we need to find S13. So here, a is equal to the first term, which is 5 over 2, and then d is the common difference, which, as we've talked about before, it keeps going up by a half, and then n, it's S13, so n is equal to 13. So therefore S13 is equal to n over 2, so 13 over 2, and then 2a, so it's going to be 2 times 5 over 2 plus n minus 1, so 13 minus 1 times d, which is a half, and if you put this into your calculator, it's equal to 143 over 2. So this is the sum of the first 13 terms. Okay, so here's an example question where we're told an arithmetic series has a first term of minus 81 and a common difference between consecutive terms of 8. And for part A, we need to find S12. Okay, so here we're going to use this formula here for Sn, where A is the first term, which is minus 81, and then D is the common difference, which we're told is 8, and then n is the nth term, which we're going up to, and as we're trying to find S12, this is going to be equal to 12. So therefore S12 is equal to n over 2, so 12 over 2, and then 2a, so 2 times minus 81, plus, and then n minus 1, so 12 minus 1, and then multiplied by d, which is 8. And if you put this into your calculator, you find that S12 is equal to minus 444. Okay, and then for part B, we need to find the least number of terms the series needs for the sum of the terms to be positive. Okay, so as it talks about the sum of the terms, this is talking about Sn, and it needs this to be positive, so it needs this to be bigger than 0. So what this question is actually asking us is to find the value of n here, where Sn is bigger than 0. And the way that we're going to do this is we're going to use this formula here, where a is equal to minus 81 and d is equal to 8, and we're going to plug in the value of n. We're going to plug in these values, and then we're going to say it's bigger than 0, and we're going to rearrange in order to find the value of n for which this occurs. Okay, so if we use this formula here, so it's going to be n over 2, and then 2a, so 2 times minus 81, and then plus n minus 1 multiplied by d, which is 8, like this here, and this is bigger than 0, and we need to find what n is for this to be true. Okay, so if we rearrange, it's going to be n over 2, and then 2 times minus 81 is equal to minus 162, and then I'm going to move this 8 to the front of the bracket, so it's going to be 8, and then n minus 1, like this here, and this is bigger than 0, and if we simplify this, it's going to be n over 2, and then minus 162, and then 8 times n is 8n, and 8 times minus 1 is minus 8, like this here, and this is bigger than 0. And if we simplify this further, it's going to be n over 2, and then minus 162 minus 8 is minus 170, and then plus 8n, and this is bigger than 0. We have this 2 denominator here. Here we could just multiply both sides of this inequality by 2, so it cancels out this denominator and leaves us with n. I'm going to write this the other way around as 8n minus 170 is bigger than 0. Now from here you might be tempted to divide both sides by n to just leave us with 8n minus 170 is bigger than 0. If you did this, this would give you the correct answer, but if you did this in an exam, I think you would lose marks, because you can't divide by n here, as n could be equal to 0, and therefore you're technically dividing by 0, which mathematically you can't do. You might be a bit confused by this, because if you kind of contextualize it like this, you can't have like S0, you can't have like 0 terms. You kind of need to view this inequality here kind of independent of the question. For this inequality here, n could be equal to 0, so therefore you cannot do the step where you divide both sides by n. The way that you should solve this inequality here for n is expand this bracket, so it becomes 8n squared minus 170n is bigger than 0, and you should treat this like a quadratic inequality to solve, as we talked about in year 1 of chapter 3. Okay, so we have this quadratic inequality here. Now, to solve quadratic inequalities, firstly, we're going to replace this inequality sign with an equal sign. So we're going to say this is 8n squared minus 170n is equal to 0, and then we're going to solve this quadratic equation here. So let's factorize out the n, so it becomes n 8n minus 170 is equal to 0. So this means that either n is equal to 0 or 8n minus 170 is equal to 0. So this means that 8n is equal to 170. So this means that n is equal to 170 divided by 8, which if you put into your calculator is equal to 21.25. So this is the roots of this quadratic here. So if we sketch a quick graph, so if we say that this is the y-axis and this is the x-axis, this should technically be the n-axis, but we'll just call it the x-axis. So if we draw this quadratic here, this 8n squared minus 170n, it's going to be a positive parabola like this here, and its roots are n is equal to 0 and n is equal to 21.25. Okay, so we're looking for where this quadratic is bigger than 0, so it's positive. So this is here and here. Now we're not interested in this section here because this is where n would be negative, and n can't be negative. We can't have like negative terms. So we're interested in this section here. So we can see that this section is where n is bigger than 21.25. Okay, now obviously n cannot be equal to 21.25 because you cannot have a decimal for kind of the nth term. So we're looking for the smallest whole number that is bigger than 21.25. So therefore n is equal to 22. So therefore the least number of terms the series needs for the sum of the terms to be positive is 22 terms. S22 is bigger than 0. Anything less than this, so S21 or S20, etc., will be negative. S22 is the first kind of sum of the terms where it's a positive number. Okay, so one of the proofs that you need to know going into your exams is the proof for SN for an arithmetic series. This is talked about in the specification as one of the proofs that you need to know, and the method to do it is quite unusual, and I would recommend you remember how to do it going into your exams. Okay, so SN, the actual definition of it is the sum of the first n terms. Okay, so this here is what Sn actually is. Okay, so this is the first term a, and then this is the second term a plus d, and then this is the third term a plus 2d, and this goes all the way up to the last term, which is the nth term. This is the formula for un, a plus n minus 1d. Okay, and then this is the second to last term here, a plus n minus 2d, like this here. What we're going to do, we're going to write this again, but we're going to write it in reverse order. Okay, so what we're going to do, this last term here, we're now going to write this first, and then this second to last term here, we're going to write this second. We're going to do it in reverse order, such as that the last term here now is the first term here, which is a. And what we're going to do, we're going to add these two equations together. Okay, so here we've got Sn plus Sn, which is going to be 2Sn, and then this is going to be equal to, and the way that we're going to add these together is we're going to do it term by term. So the first term here, we're going to add it to the first term here. The second term here, we're going to add it to the second term here. We're going to do this all the way for the last terms as well, where the last term here, we're going to add it to the last term here. Okay, so if we focus on these two terms here first, so the first term here is a, and then we're going to add this to the first term here, which is the a plus n minus 1d, and then this is going to be equal to a plus a, which is 2a, and then plus n minus 1d, like this here. Okay, now if you do it for the second term here, so here we have the a plus d plus this term here, which is a plus n minus 2d, like this here. We've got a plus a, which is 2a, and then we've got n minus 2d plus d, which is going to be n minus 1d. And you can see that these are the same thing, and you actually find that if you add all of the terms together, like I've just said, all of them give out the same value of 2a plus n minus 1d. Okay, that's how it works. So all of them give out this value, and this is going to happen n times because we have n terms here that we're adding together for both of the SNs. So we're going to have n multiplied by this 2a plus n minus 1d. Okay, so we have 2SN is equal to this here. We want to make SN the subject, so we're just going to divide both sides by 2 here. So we get SN is equal to n over 2 2a plus n minus 1d. And this here is the formula, and this is the proof. As I said, I think this is quite an unusual method, kind of adding the SN equations like this and then adding them term by term, and you find that all of them give this 2a plus n minus 1d. Just one more thing I want to mention quickly is this question here, where we need to prove that the sum of the first n natural numbers is this here. Now, the reason I want to mention this is, firstly, it's mentioned in the specification as a proof you might need to know, and secondly, it's kind of a common exam question. Now, normally it won't be find the sum of the first n natural numbers. It will be something like find the sum of the first 50 natural numbers, for example, but the method is the exact same. Now, they do an example of this in the textbook. It is example 4 in 3.2, and the way that they do it is very complicated. They kind of do it from first principles. You don't need to do it that way. You can just use the formula for Sn, which is this here. Now, the first n natural numbers, if you don't know what a natural number is, the natural numbers are just the positive integers. Okay, so the sum of them is just going to be 1 plus 2 plus 3 plus 4 plus 5, like this here. And this is an arithmetic series where a, the first term, is 1, and d, the common difference, you can see that for each term it keeps going up by plus 1. So therefore the common difference is 1, and then we're trying to find the sum of the first n natural numbers. So if we just plug this into Sn, it's going to be Sn is equal to n over 2, and then 2a, so 2 times 1, and then plus n minus 1 times d, which is 1. So therefore Sn is equal to n over 2. 2 times 1 is 2, and then n minus 1 times 1 is just going to be n minus 1, like this here. So therefore Sn is equal to n over 2, and then 2 minus 1 is 1, so this is 1 plus n. So therefore Sn is equal to n over 2 times 1, which is n over 2, and then n over 2 times n, which is n squared over 2, like this here. And this is the formula that you need. Okay, so I think this is quite a good question from one of the old spec papers. I've given you the formulas down here for Sn because they're given to you in the formula booklet, so you have access to them in the exam. If you want to have a go at this question yourself, pause the video now and I'll go for the answer. Okay, so for part A, we need to calculate the sum of all the even numbers from 2 to 100 inclusive, and we're also given the series here. Okay, so we need to use the formulas down here. So for this one here, we need N, A, and D. Okay, so A is the first term, and we can see that the first term here is 2. D is the common difference, and going from 2 to 4 and then 4 to 6, we are adding 2, so the common difference is 2. So n is equal to the number of terms. Now remember, it's even numbers. If we were doing natural numbers up to 100, n would be equal to 100, but as we're only doing the even numbers, this is cut in half, so n is equal to 50, so therefore it's going to be S 50 is equal to n over 2, so 50 over 2, and then 2a, so 2 times 2, plus n minus 1, so 50 minus 1, multiplied by d, which is 2. And if you put this into your calculator, this is equal to 2550. So this is the sum of the first 50 terms. Alternatively, you could actually use this formula down here, because we know that the last term is 100. So therefore we could say that S50 is equal to n over 2, so 50 over 2, a, which is 2, plus L, which is 100, and if you put this into your calculator, it also gives out the 2550. Okay, so for part B, we're told in the arithmetic series k plus 2k plus 3k all the way up to 100, k is a positive integer and k is a factor of 100. And for the first part, we need to find in terms of k an expression for the number of terms in this series. Okay, so what this question is asking us is we need to find the total number of terms in this series, and it's going to be an algebraic expression in terms of k. Now, I think this question is actually a bit difficult in order to actually figure out how to do this. We need to find the total number of terms in this series. So firstly, let's figure out A and D for this new series that we've got here. So A is the first term, and we can see that the first term is K, and D is the common difference, and we can see that the difference between K and 2K and 2K and 3K is we're adding K. So therefore the common difference is K. Now we need to find the total number of terms in this series, and we can see that the last term in this series is 100. So for this last term of 100, if we just figure out what term this is in terms of the nth term, so we find the value of n, this will be the total number of terms in the series because this is the last term. So what we can do, rather than using Sn down here, we're going to use the formula for Un. Remember, this isn't given to you in the formula booklet. So this is A plus n minus 1d. What we're going to do, we're going to sub these values in here. So this is A, which is k, plus n minus 1, and then d, which is k, and we're going to say that this is equal to 100, and we're going to rearrange in order to find n, and then again, because n is the final term in this series, this will be the total number of terms in the series, this value of n. So in order to find n, let's rearrange this. So let's quickly rewrite this as 100 is equal to k plus, and then move this k to the front, so it's k n minus 1. So let's find the value of n. So this is going to be 100 is equal to k, and then k times n is kn, and then k times minus 1 is minus k, like this here. This k will cancel out with this minus k to leave us with 100 is equal to kn, and then divide both sides by k, so we get n is equal to 100 over k. So this is the term that 100 is, so therefore as this is the last term, this is the total number of terms in the series. So there are 100 over k terms. Okay, and then for the second part of B, we need to show that the sum of this series is this here. And as we showed in the first part of B, that there is 100 over k terms. Therefore, we're going to sub in n is equal to 100 over k. Now, I do quite like this question, but one of the problems with it is that this is another question in which we can use this formula for Sn here, where it's n over 2 a plus l, because again, we know that the final term in the series is 100. Again, normally we don't use this formula, we normally only use this one, and you can still use this formula for this question. However, this is another example where you can actually use this more unusual one, because we can say that a is equal to k, and we can say that L is equal to 100, which is the last term. So we can say that Sn is equal to n over 2, so n is 100 over k, so as it's n over 2, we're going to say it's 100 over k divided by 2, like this here, and then A, which is k plus L, which is 100. If we simplify this, we have 100 over k divided by 2, so 100 divided by 2 is 50, so this is 50 over k, and then we have the k plus 100, and then if we expand this here, we've got this 50 over k times k, so this will cancel out the denominator and leave us with 50, and then this is plus 50 over k multiplied by 100, which is 5,000 over k, like this here, which is what's required. Okay, and then for part C, we need to find in terms of k the 50th term of the arithmetic sequence, this here, 2k plus 1, 4k plus 4, 6k plus 7, giving our answer in its simplest form. Now, this is a sequence, it's not a series, so we're not worrying about Sn here. We're going to use the formula for Un, which is a plus n minus 1. D, like this here. Okay, so A is the first term, and we can see that the first term is 2k plus 1. Okay, so D is the common difference, and we can see that the difference between 2k plus 1 and 4k plus 4, so it's going to be 4k plus 4 minus 2k plus 1, which is going to be equal to 4k plus 4, and if we expand this bracket here, it's going to be minus 2k minus 1. If you expand this, this is going to be equal to 4k minus 2k, which is 2k, and 4 minus 1, which is 3. So therefore, the common difference is 2k plus 3. You can confirm this further if you want by finding the difference between 6k plus 7 and 4k plus 4, which will also be 2k plus 3. And then n, we're trying to find the 50th term, so n is equal to 50. So therefore, u50 is equal to a, which is 2k plus 1, and then plus n minus 1, so this is going to be 50 minus 1, which is 49, multiplied by d, which is 2k plus 3. We need to write this in its simplest format, so this is going to be 2k plus 1 plus, and then 49 times 2k is going to be 98k, and then 49 times 3 is going to be 147, and this is going to be equal to 2k plus 98k, which is 100k, and then 147 plus 1 is 148. So this here is the 50th term in its simplest form.